Hello students, in this video we are going to discuss about the one more sorting algorithm, quicksort. In previous video we already discussed about bubble sort and the complexity of bubble sort and how to use bubble sort with virtual labs. How can we do the bubble sort? So we discussed already. So in this video we are going to see how quicksort will work. So here in quicksort algorithm, array of n elements will be there. Those are integers. So if array only contains one element, there is no need of sorting. So just return it. Else, pick one element to use as a pivot. Okay, pivot, and partition elements using into two subarrays. So that means how can we partition it? So elements less than or equal to pivot, that is one array. Elements greater than pivot, that will be the second array. Okay. So using the pivot, we will divide this array. So less than elements pivot, that will be one array, and greater than elements greater than pivot, that will be another array. Okay. And again apply the quicksort into two subarrays, return the results. Okay, this quicksort algorithm use divide and conquer method. That means the array will be divided into sublists. Again the sorting algorithm will be applied on the sublist, the result will be combined. Okay, this is called the quicksort. Now we will see with example how it will be work. So okay, so here I'm going to give one numerical example I'm showing. See, so here the numerical example, this is here it is containing 40, 20, 10, 80, 60, 50, 7, 30, 100. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9 elements are total. So here we are going to apply the quicksort algorithm on this array. Okay, so now we will see how it will be using. Okay, so here there are a number of ways to pick the pivot element. In this example, we will use the first element in this array. Okay, there are so many ways to pick the pivot. Here I'm going to explain only first by taking the first element as a pivot element. Okay, so pivot element. So now we'll see how it will be. So partitioning the array, how can we partition the array? One subarray that contains the elements greater than or equal to pivot and less than or equal to pivot. Okay, so already told it. So here I have taken, this is the pivot index. Okay, it is 0 now. This is the index elements and these are the array elements. Okay, and here this is the left index we will take next to pivot. We will search for the big element. Okay, from the left side we will search for the big element, and from the right side we will search for the small element. That is called right index and this is called left index. Okay, so what is the first step here? While data of left index less than or equal to data of pivot index. Okay, so data of left index, what is left index? Data of left index is 20. Okay, if it is less than pivot, that means 40. Okay, 20 is less than 40, so increase the left index. Okay, so move the left index. Left index is equal to left index plus 1, that means 1 plus 1, it is equal to 2. Okay, so now we will see what will happen. Okay, so left index is increased. Here we got, okay, this is 10 we got here. And again we will check the same condition, that is data of pivot index, data of left index is less than data of pivot index. Okay, yes, it is less than. So again we need to increment it. Okay, increment it. Okay, so here the condition will change. Okay, the data of left index is greater than the data of pivot index. Okay, it is greater than, then just stop it. So you need to move to the right index now. So what will be the right index? What we need to check? So data of right index is greater than pivot index. If it is greater than this, okay, so here just look at the small, right for small, left for the big. Just remember this. Okay, so here from it is 100, 100 is 40, greater than 40, so just increase the decrease the right index. That means 8 minus 1, that is equal to 7. Okay, 8 minus 1, that is equal to 7. Okay, so 7. So 40 and 30. Okay, 30 is less than 40. Just stop here. Okay, just stop here. So now left index is 3 and right index is 7. So what is the third step here we need to do? If left index is less than right index, okay, left index is 3 is less than right index. No, don't check the elements, only index. Check the index. 3 is less than 7. Then swap the data of these two. Okay, left index and right index. Swap this data. Okay, so I'm swapping this. So 30 here and 80 is here. This is the third step. Okay. After swapping, again, we need to go to the first step here. Okay, after swapping, we need to go to the first step here. Again, we will check. Okay, this is the pivot index and this is the left index and this is the right index now. Okay, we just check. Okay, if data left index is less than data of pivot index, is it is 30 is less than 40. So what will happen? Just first step we are going to do. So again, increase this. Okay. So 60 is greater than 40. So just stop here. Now we will check the right index, second step. Okay. So 40 and 80. Just check it whether it is greater than. Okay. Move it. Okay. Move means decrease. So here. So here it will. So 7 is less than 40. Just stop here. So check the left index and right index. Left index is 4 and right index is 6. Okay, the third step. Okay, left index is less than right index. Swap this element 60 and 7. Okay, I have swapped. Okay, then again go to the step 1. First step we need to go. Okay, again after this we need to go to the first step. So again, first step 40 and 7, just we will check. 7 is less than, just move. 50 is greater than, just stop here. And from the right, we will check. Okay, 60, it is greater than 40. We need to check the small. So 7, okay, sorry. 7 for second step we will. So 750, 60, 50, 50 also greater than 40. So 7 is less than 40. Okay, so right index will is 4. Now left index is 5. So here what we need to do, we will just check the this one. If left index is less than right index, no, it is not. Okay, else what we need to do, if left index is greater than right index, swap. So swap, which elements we need to swap? Swap the pivot and data of right index. Okay, that means 7 and 40 we will swap. Okay, so here we swapped that. So here it will become the pivot index, that is right index will become the pivot index, left index as it is, and pivot this will be the 7. It will be 7 will be swapped here. So now the pivot element is 40 here. Always it will not change. 40 will be the pivot element only. Index will be changed. So here we swapped the elements, that is pivot and element and the data of right index, that is 7 here and 40 here. So now just look at the array, that is these elements are less than the pivot and these elements are greater than the pivot. Okay, so 47, 20, 10, 30 is less than this 40, and 50, 60, 80 and 100, these are greater than. Okay, again we need to apply the quicksort algorithm on both these arrays. Okay, and here we need to apply all the quicksort algorithms in these arrays and combine the results here. Okay, so see what will happen next time if you are looking at. Okay, so see here, this is the 40 and these are the less than and it is greater than. Array is divided. Okay, so now quicksort of subarrays and subarrays we need to start. So here again we will see 7, 20, 10, 30, and here it is a pivot index. Okay, this is the left index and this is the right index. So how can we do? So from the 7 we need to check whether it is from the left we need to check the big element. Okay, so 20 is already big element, it will be here only. Okay, in one right index we need to check the small element. Just check it out. 30 is not small, 10 is not small, and 20 is not small. So 7 will be the small element. Okay, so what will happen? 7 will be the small element here. So 7 will be the small element. So here what I am doing here, so the right index, it will move, it will decrease, it will decrease. So this will become our right index. Okay, this will become our right index. So 0 is the right index and 1 is the left index. According to the fourth, that is fourth step, let me show. That is, if left index is less than right index, we will swap those. But else, if left index is greater than right index, swap the pivot and data of right index. Okay. So what will happen here? Here left index and pivot index, both are same only. So there is no need of exchanging. Here it will be the partition. Here this will become the pivot. Okay, it will be partitioned here. Okay, the list will be partitioned like this. Okay, this is 7 and 20, 10 and 30. Again we need to apply quick sort in this. Again we need to apply in this list quick sort. So how can we apply? This will be our pivot. Okay, this will be our pivot. So here I'm writing this P. Okay, this will be left, this will be the left, and this will be right index. Okay, in this area I'm going to do this. Okay, so from the pivot there's a 20. From the left we need to search for the big element. Okay, 10 is a small element. Okay, 30 will be our left. Okay, 30 will be, that means our left. From here we need to search for the small element from 20. Okay, so here, so see here how what will happen. This will be your left index and this 3 and the right index we will search for a small element. 30 is greater than 20, so the right index will become 2. Okay, the right index will become 2. Left index is 3 and right index is 2. It is right index is less than left index. Okay, then what will happen? We will exchange the P and right index. Okay, the list will become 10 will be here. Okay, and 20 will be here. This is our pivot element, it will become, and 30 will be here. Okay, so what will happen? So this will be P, and left hand this list, it is less than pivot, and it is greater than. So only one element is there, so no need of sorting here. So how it will become the list? 7, 20, 10, 20, 30. This will be, here we will return the 7, here we will return the 20, 10 and 30. So list will be sorted here. What will be the second half? 50, 60, 80, 100. It will also check, this will also sort. So the list will become, how it will become? See, this is 7, 10, 20, 30, and after that it is 50, 60, 7, 10 and 20 and 30 here. Already we have seen the 40 was the first pivot. 40 and 50, already it is a sorted array. 50, 60, 70 and 80. So the whole array will become like this. Okay, it is a sorted array. So assume that keys are random, uniformly distributed. The best case is n log n. Okay, so here worst case, what will be the worst case? So here what will be the worst case? Here assume that first element is chosen as a pivot. Here every time if you are doing this, so it will be the list is dividing like first element as a pivot and rest all will be divided like this. Only one element we are taking, only one element is, and list is dividing like this, one element and rest of the elements. Okay, again if you are doing like this, This is the pivot and these are the elements. So what will happen? The worst case running time will be n square. Always the list is divided like this. First time n, next time n minus 1, okay, the list is divided, and next time n minus 2, the list is divided. If you're combining all this, okay, so the worst case complexity will be order of n square in quicksort, okay, quicksort. So that's all. We will see one more example with this, okay. Hope you understood.